So let's try very hard to do problems 1 through 3 without what I'm going to refer to as cheating, right? Because it would be very easy for me to go back here to this slide on the 5th page and just locate these on the circle and find the x coordinate, find the y coordinate, right? Sine is y and cosine is x, and do this very easily. But the problem is, like I said before, you're not going to just always walk around with that chart in your pocket. So if you have memorized what I had told you to do in the last video clip, have these memorized. Okay, if you know these, then you can find many other values, right? Many other, the sine and the cosine of many other angles. So anyway, let's talk about how to use reference angles to do these. And as I've mentioned before, all of calculus is done in radians. I know for me, I have a much easier time thinking in degrees. So whenever I see a value in radians, I convert it into degrees. And then if I have to answer in radians, which I do in calculus, then I just convert it back later, back into radians. So anyway, if I want to change 3 pi over 4 into degrees, I remember from a past lesson that pi radians is equal to 180 degrees. Okay, so this goes in here 45 times, 3 times 45 is 135. Okay, so then I'm going to draw this angle, 135, and I want to know what its reference angle is, right? So this is 135 that I drew here in red, and the reference angle would be the angle, right? If I reflected this through the y-axis, okay, this angle and this angle would be the same. Okay, and a reference angle is always a first quadrant angle, right? Because these are the angles, they're all first quadrant angles that you've memorized. Okay, so going back here, if this is 135, how do I figure out what this angle here, my reference angle is? All right, and I hope you recognize without too much trouble that you would have to do 180 minus the 135. All right, since halfway, a rotation halfway around that circle is 180. Okay, and that would get me 45. Okay, so this is 45 here, this is 45 here. So these points would have the same x and y coordinate, other than the fact that the x value here would be positive, the x value here would be negative because we're in the second quadrant. But anyway, we're looking for sine. Sine is the y coordinate, and you should have memorized then that sine of 45 degrees is radical 2 over 2. And we are in the second quadrant, and so the y value is still positive. So therefore, this would be positive. So I'm going to put a positive in front of it. Right? So this would be positive radical 2 over 2. All right, so next example, I want to find cosine of 210 degrees. All right, so again, draw it. And it's going to take me down here into this third quadrant. Okay, and so let's say this is the point that I reach when the ray has a value of 1. Right, the ray has a length 1, so I'm on the unit circle. So here's my 210. Now the reference angle here, right, if I were to reflect through the origin, this angle here and this angle here would be the same, right? So whatever point this is, right, whatever the coordinates are here, I'm going to call it AB for the moment. If the coordinates here are AB, and I take this and I reflect it through the origin, the coordinates here are negative A, comma, negative B. Right? So I want to figure out what this angle is. And I hope it's not too hard for you to recognize that I would, this is 180 to this point, and then I would have to go an additional 30 degrees, right? So I would actually have to do the 210 minus 180 to get 30 degrees, right? So this reference angle here is 30 degrees. There's 30 degrees from this ray here to this ray here. And this angle, which is equivalent, would be 30 degrees. So I would recognize that, let's see, cosine is my x, and x would be negative down here in the third quadrant. So I'm going to say, okay, cosine of 210 is equal to negative cosine, right? Because the x coordinate has the opposite sign, the negative cosine of 30 degrees. And again, I hope you have that memorized. Cosine of 30 is radical 3 over 2. So my answer would be negative radical 3 over 2. All right, so you try cosine of 315 degrees. So first draw it. And then try to determine the reference angle. Okay, so again, imagine I have symmetry here, which I don't quite, it's close, but not quite. Okay, so my reference angle is this angle here that I drew in yellow. So if I take this ray and I reflect it over the x-axis, right, I get this equivalent angle over here in the first quadrant. So this is my reference angle. All right, and if this is the point that lies on the unit circle AB, then the point down here, I've taken this point and I've reflected it through the x-axis. So the point down here is a negative b. So cosine is x, so cosine is going to be positive. And you should have found your reference angle by doing 360 degrees, subtracting 315, all right, to get 45 degrees. All right, so I have a reference angle of 45 degrees. I am in the fourth quadrant, so cosine is positive. And then I have memorized that cosine of 45 degrees is radical 2 over 2. So again, it would have been much easier to just say, okay, I want to know the cosine of 315 degrees. Here it is, right? Here's 315 degrees. Cosine is x. There we go. Okay, that's much easier. And I have no way to stop you from doing the problems that way on your homework and on the test or on the quiz. But I thought long and hard and carefully about how I could make sure you understand reference angles, even when I have no way to monitor whether or not you are using the unit circle with all the values labeled. And so question 4 and 5 are going to be very close to the kinds of problems that I'm going to put on the quiz. All right, to make sure you understand this, even though you can have that circle in front of you. All right, and so the first question asks you to circle all angles below that have a 20-degree reference angle. So here's 20 degrees. And let me encourage you when you do any of these reference angle problems to take that ray, oh gosh, take that ray, reflect it through both the x-axis and the y-axis. Oh my goodness, I can't get these lines straight. So let's see, reflect it here, here, and here. Gosh, that's ugly. Okay, so anyway, this would be 20 degrees. This would be 20 degrees. And this would be 20 degrees. All right, and if I am 1 unit away from the origin, all these points here that I'm highlighting in yellow, right, if this is the point AB, then all these other points are AB with just different positives or negatives depending on what quadrant I'm in. So for 20 degrees, my reference angle would be, or that would be a reference angle for this angle right here that I just drew in blue, this angle right here that I just drew in green, and this angle right here that I am drawing in purple. Okay, so those are all the angles that would have a 20-degree reference angle. So if I come over here and I start circling my choices, the angle in blue is that. Okay, the angle in green, so that would be 20 more than 180. So the angle in green would be 200. The angle in purple would be 20 away from a complete rotation. So that would be this one. There's a couple other choices here that I would want to circle as well. This is 20 degrees, negative 20 degrees, right? Negative 20 degrees is the same angle, is coterminal, I should say, coterminal with 240. And also this angle here, 380, right? That's a full rotation plus up 20 more. So 380 would also be coterminal with my 20-degree angle. All right, and so it would still have 20 degrees as its reference angle. Okay, so those are all of the things that you would pick. So there's a rule for determining a reference angle. And I strongly encourage you to draw a diagram like I just did here instead of trying to memorize a rule. You know I'm not a big fan of memorizing rules because when you memorize rules, you forget them. But the rule is that when you're finding the reference angle and you're in the second quadrant, you do 180 minus whatever angle you are given so that you can find the reference angle. Okay, in the third quadrant, the angle will be bigger than 180. So you have to do the angle, take away 180, to find the reference angle in the third quadrant. And then over in the fourth quadrant, you do 360. Take away whatever the angle is. So if you have an angle of like 330, right, you would do 360 minus 330. Okay, so that's the summary of how you find a reference angle, depending on what quadrant you're in. And so notice you never subtract or add to 90 or 270, right? You're always comparing to the x-axis. So if you look back here, a couple of my distractors, right? All of the wrong answers, I relate to either 90 or 270, right? So here I subtracted 20 from 270. Here I added 20 to 270. All right, I never used 270 or 90. Okay, so those were my distractors. So anyway, I'm going to put something like this on the quiz, and I am also going to put something like this on the quiz to make sure you understand reference angles. So refer to the diagram below. So sine of 25. So if this is 25, this is not drawn to scale. Sine of 25, so remember, sine is y, right? So sine of 25 would be b, whatever value that was. And then cosine of 25 would be my x. Okay, and this says, find and sketch a second quadrant angle whose reference angle is 25. Okay, so remember in the second quadrant, go like that, I would take this, reflect, again, imagine that's a perfect reflection. So this is what I do to get into every single other quadrant. And then I reflect this through the origin. Again, not drawing well to scale. Okay, this point would be a negative b. This point here would be negative AB. And this point would be negative A, negative B. Okay. So if you spend a minute, maybe pause the video and try to find the angle in the second quadrant that has 25 as its reference angle. Okay, so again, this is 25. This is 25. And this is 25 degrees. Okay, so what are the angles that have that as its reference angle? Okay, so pause the video and try to find that in quadrants 2, 3, and 4, and then find sine and cosine of the angle that you stated. Oh, I'm sorry, I just saw a typo here in D. That should say fourth. In D, we're down in the fourth quadrant. Okay, but these would be the angles that have a 25-degree reference angle. All right, I subtracted from, I did 180 minus 25. Here I had to add the 25 to the 180. And here I subtracted 25 from 360. All right, sine and cosine then. So sine is y. So sine would be b. Cosine would be negative a. so that goes together and that goes together. All right, down in the third quadrant, both are negative. All right, so this would be negative B, negative A. All right, and then in the fourth quadrant, oh, I've left off that last little question. That's all right. I had a typo in it and I left off the question. So if I had to find the sine of 335 degrees, so sine is y, so that would be negative b, and then the cosine of 335 degrees would be positive a. All right, so let's take another break.